Example 2, we want to sketch the function given by y is equals to x minus 2 over x plus 1 times x minus 3. So a couple of things that we should pick up on straight away as soon as we see this function is that it's got vertical asymptotes. There are two of them. First one is going to be given by x equals to -1 because we can see that if x equals to -1, we substitute it into the function, the first factor in the bottom becomes 0, okay, thereby making my whole function undefined. And the second vertical asymptote that we have is going to be at x is equals to 3, right? So these are our two vertical asymptotes. And after this, we can see that the degree of the numerator is 1, and the degree of the denominator, if we expand the whole expression, is going to be 2. And what that implies is that as my x value gets larger and larger, my numerator is going to be a big number. And then my denominator is going to be like a big number times a big number, which is a big number squared. So if I have infinity kind of thing at the top and then I'm dividing it by infinity squared kind of thing in the bottom. So what that tells me is that as my x value gets larger and larger, my y value is actually going to get smaller and smaller, right? So I can say that as x approaches infinity, my y value is going to go towards 0. Okay, we can verify this by taking a big number and substituting it in, right? So for example, like 100, and I'll do this in a moment. And this allows us to determine the horizontal asymptote, which is going to be given by y is equals to 0, or in other words, the x-axis, right? So as soon as we have this, we pretty much have the framework to our curve. So we've got a vertical asymptote at x equals to -1. So let's just say, roughly speaking, this is x equals to -1. And then we're going to have our second vertical asymptote at x equals to 3. Let's say it's going to be here. Okay, so this is going to be x equals to 3. And we know that the x-axis is a horizontal asymptote in this case. So as soon as we've got the framework out, we should immediately test for a couple of things, right? So each of the vertical asymptotes, we need to test to the left and to the right. So for example, at x equals to -1, I want to know what is happening to the graph to the left of the vertical asymptote. So let's say I've got x equals to -1.01. I want to find the corresponding y value, and then I want to do the same for x equals to -0.99, which is a point that lies to the right of my vertical asymptote. Okay, then I want to do the same for the second vertical asymptote at 3. So at x equals to 2.99, I want to check out what is happening to y, and I want to do the same for x equals to 3.01. Okay, and then after I have checked out what is happening on the left and right of each vertical asymptote, I want to know what is happening to the curve for large value, a large positive value of x, and I also want to see what happens to the curve for a large negative value of x. So let's choose x equals to 100 to represent my large positive value of x. So when x equals to 100, I want to know its y value, and I also want to know the same for x equals to -100. So taking each of the 6 x values here and substituting them into the equation, we're going to get -75 for the y value when x equals to -1.01. When x equals to -0.99, we're going to get y is equals to +75. When x equals to 2.99, we're going to get y is equals to -24. And when x equals to 3.01, I'm going to get y is equals to 25. Okay, now when x equals to 100 and we substitute this into the equation, okay, we're going to get a y value of about 0.01. And when x equals to -100, we're going to get about -0.01. Okay, so what this is telling me, let's start from the first two. When x equals to -1.01, my y value is -75. What that tells us is that my y value is very big negative number. Okay, so when I'm to the left of my first vertical asymptote, my curve should come from -infinity, so it's down there. Okay, and when I move to the right of my vertical asymptote, okay, my y value is 75, which is a positive number. Okay, it's a positive big number, so therefore that indicates that when I'm to the right of my vertical asymptote, my curve is all the way up there. So my second vertical asymptote at x equals to 3, to the left at x equals to 2.99, my y value is -24. Now, -24 might not sound like a very big number, but it's pretty big comparatively. Because what we're supposed to say here is that when we're to the left of the vertical asymptote, the negative 24 here represents the fact that my curve is going to be all the way down here. But if I'm not convinced by that, what we can do is we can pick a point which lies even closer to the vertical asymptote x equals to 3. Let's say x equals to 2.999 instead. Okay, and if I take that value of x and I substitute it into the equation, we should be able to see that the y value becomes an even larger negative value. Okay, you guys can try that just to verify that if you want. And when I'm at x equals to 3.01, my y value is 25, which is a positive big number. So when I'm to the right of the vertical asymptote, my curve is all the way up here. So when I get to x equals to 100, okay, that's supposed to represent what happens to the curve for the large value of x, large positive value of x. My y value turns out to be 0.01, which is telling me that I'm very close to the x-axis, but I'm a little bit above the x-axis. Okay, so therefore the curve is going to lie above the x-axis like that. And when x equals to negative 100, okay, my y value is at negative 0.01, which also means that as my curve is moving towards the left, okay, my y value gets very close to 0, but it's a little bit smaller than 0. So therefore my curve is underneath the x-axis. So if I join everything together, okay, taking note that what I'm missing right now are the intercepts. So if you solve for the x and y intercepts, I mean, it's not very difficult. My equation is given by y is equals to x minus 2 over x plus 1 times x minus 3. So if I let y equals to 0 for x intercepts, we are going to get x minus 2 over x plus 1 times x minus 3 is equals to 0. We multiply the denominator across, so effectively we're just solving x minus 2 is equals to 0, and that tells us that the x-intercept is at x equals to 2. If I want to look for the y-intercept, we need to let x equals to 0 for the y-intercept. And this is going to be the easy one because all I have to do is substitute 0 into the equation. So we get 0 minus 2 over 0 plus 1 times 0 minus 3. And that's just going to be negative 2 over negative 3, which is positive 2/3. Okay, so that's going to be our y-intercept. So coming back to the graph, okay, so the y-intercept is going to be at 2/3. And the x-intercept is going to be at 2. So the middle part over here, we know that it starts from up here and it comes down here. So therefore, if I join this part together, it has to look something like this. So the y-intercept here is going to be 2/3, which is what we found a moment ago. And the x-intercept over here is going to be at x equals to 2. And you can see that my scale over here is a little bit off. Okay, so yours probably will be a bit better. And that's going to be this part in the middle. If I look at the part on the left, I've got an arrow that goes across here. And then an arrow that goes down there. No x-intercepts. So therefore, it's just going to look like this. Okay, and the part on the right is exactly the same. I've got an arrow up here and an arrow that goes across. So if I join this part here together, it's just going to look like that. Okay, so this is essentially what the rational function y is equals to x minus 2 over x plus 1 times x minus 3 looks like. And this concludes example 2.